Our next unit in this class is a unit on propositional logic. The fundamental unit for propositional logic is, you guessed it, the proposition. Propositions are basically like a fancy word for sentences or statements. It's anything that has a truth value. And we did a whole unit before on a certain type of proposition, the categorical proposition. So those are all examples of certain propositions. All cats are mammals. But basically any sentence that has a truth value can count as a proposition. For example, UConn will win the game tonight. That's a proposition. It's either true or it's false. Cats are mammals, also a proposition. Lola is a cat, also a proposition. Again, all of these statements have a truth value. And the way that propositional logic works is it allows us to build fundamental units of sentences called propositions together using what are called connectives or operators. And then we can form more complicated sentences and arguments based on these sentences, and we can learn rules about how different propositions relate to one another. And propositions are the ingredients to all arguments. So there are 5 basic connectives that we can use to symbolize any sentence. The connectives are not, and, or, the conditional, or if then, and the biconditional or equivalence, or if and only if. Each of these connectives has a symbol given in our textbook. The not connect, the connective for and, the symbol is a dot. The symbol for or is a wedge. The symbol for a conditional is a sideways horseshoe. The equivalent symbol is this triple bar here, 3 lines, like a special equal sign. Some other textbooks use different symbols. I've showed them here, an ampersand or an upside down wedge for and, an arrow for a conditional, and a double-sided arrow for a biconditional. So you may see these if you take logic in a future setting, but our textbook uses these symbols that I've highlighted here. So let's look at some examples. Go back to these proposition examples that I gave earlier, and let's assign each of them a letter. So call this one U, call this next one C, and call the third one L. So UConn will win the game tonight. If that proposition is called U, then the proposition that they will not win the game tonight will be symbolized by not U. UConn will not win the game tonight, or it is not the case that UConn will win the game tonight. Maybe that's because they will lose the game, or maybe that's because there's no game in the first place. The next proposition, cats are mammals, we call that C. And if we combine that with the other proposition that Lola is a cat, then we can create the compound proposition, cats are mammals and Lola is a cat. Now, interestingly, both of these, if we combine them together, imply this third proposition that we can call M, Lola is a mammal. So here, with this sentence, I've indicated that truth here. If C and L, then M, by indicating that relationship with a conditional. So we can look at some examples for how to translate sentences into symbolic form. So in the instructions, they've given us 3 propositions. Facebook makes us narcissistic, call that F. Twitter relieves our loneliness, call it T. LinkedIn relieves our loneliness, call that L. We would translate that as F entails T or L. Here, we translate Cartier does not make cheap watches as not C, where C is the proposition that they do make cheap watches. Let's look at the next one. The next one contains 2 propositions. One is that Arizona has a national park. We can call that proposition A. The second proposition here is that Nebraska has a national park. We can call that one N. So how would the original sentence be symbolized? Well, Arizona has a national park, but Nebraska does not. So A and not N. So notice that but here is translated as an and, because the sentence is saying that both of those things are the case. Arizona has a national park, and it is not the case that Nebraska has one. And the lower, number 3, we have Stanford or Tulane has an architectural school, so we're using the or operator. Here, we're going to use the and operator. Harvard has medical school, and Baylor has medical school. Next, we're going to use the conditional operator. We've got an if-then claim here. If Chanel has a rosewood fragrance called C, then Lanvin has one called L. And then how would we translate this number 6 here? Chanel has a rosewood fragrance if Landbin does. So notice that the if here comes before the Landbin rather than coming before Chanel. So this one would reverse the order of the conditional. L, then C. If L, then C. So it's really important to get the handle on what's going on with the conditional operator. Every single logical operator is very important, but the conditional one is often one that students find confusing. So we'll go over that one a little bit more. Option 7, question 7, uses the biconditional or the if and only if operator. So that one's symbolized by a triple bar. So let's talk a little bit more about the conditional connective and what it really means. One common, easy English translation of a conditional is if A, then B. This gets translated as A horseshoe B. We can also think of conditionals in terms of necessity and sufficiency. So if A is a necessary condition for B, that gets translated as B horseshoe A. Let's look at an example to see why it gets translated this way. So here's an example of a sentence that I think is true in general. Turning in assignments is a necessary condition for passing this class. What do I mean if I state that? I'm stating that you must turn in assignments to pass the class, that if you want to pass the class, then turning in assignments is required. So if A is a necessary condition for B, then B entails A. Passing the class entails that you have turned in assignments. What about sufficiency? Sufficiency flips the horseshoe. So if A is a sufficient condition for B, then we translate that as A horseshoe B. So here's an example. If you're a cat, being a cat is a sufficient condition for being a mammal. So think of sufficiency like being enough. Being a cat, if you know something's a cat, that's enough for you to know it's a mammal. So that means if you're a cat, then you're a mammal. A, then B. The equivalence relation combines an if and an only if. So A, if and only if B. So what is an only if? Let's look at that. If we hear the sentence A, only if B, then we would translate that as A, horseshoe B. So let's think of an example to explain why it would look like that. So here's a sentence. You'll pass the class only if you pass the quizzes. If I told you that, what would I mean? I would mean that if you pass the class, then you must pass the quizzes. And so that's what A, only if B, and A, if B gets translated the opposite way, B horseshoe A. So if we have both of those, B horseshoe A and A horseshoe B, then we have a triple bar, A, if and only if B. So both of those two there are equivalent. So if we have an if and an only if, then that is an equivalence relation. So there you have it. There's the summary of the basics behind propositions and the 5 main logical connectives that we're going to be looking at within our unit on propositional logic.